Every single day, you use so many various types of computational systems. Your computer, your phone, your car dashboard, your keyboard and mouse, and your drawing tablet and headphones and a microphone, and all of these things taken together that help us humans communicate to these computers and computational systems. They all fall under the category of human-computer interaction, the design, evaluation, and implementation of interactive computing systems for human use. Having an understanding of HCI gives you a framework for understanding the history and hopefully the future of many technological systems we interact with in our everyday lives. In this video, I'm going to cover a very brief history of computing systems for individual human use, and I will give definitions and a model for understanding interactive systems. An older term for this is cybernetics. And I put this quote up here from 1954, which tells us that even in 1954, scholars and people are thinking about how communication between humans will become more and more and more pervasively intervened by a machine, meaning the cell phone in your pocket, the text messages that you're sending, maybe the email that you're currently checking while multitasking, watching this video, the videos you're posting on YouTube or whatever social media has blossomed in popularity most recently. As computation grew more and more pervasive and modern, cybernetics turned into HCI. Here's a definition. What is an interactive system? Interactive systems are computer systems characterized by significant amounts of interaction between humans and the computer. A classic example of an interactive system is the Graphical User Interface, or GUI, GUI for short. So pre-1980s, computers had command line interfaces. You have to tell the computer, hey computer, do this, and you have to type it in, and you had to rely on these complicated commands that you had to know beforehand, right? So there was no possibility of exploring. The user of the computer had to already know what the computer was capable of doing so that it could ask it to do it for it. So to make a long story very short, Xerox PARC, Palo Alto Research Center, released a graphical user interface in 1981. It wasn't that great. Steve Jobs, running Apple, saw it and released the Lisa in 1983, also not a successful commercial product. And then finally in 1984, released the original Macintosh, down there. Meanwhile, Microsoft was also working on its own graphical user interface, and in 1985, released an add-on to DOS called Windows. There was some legal struggles between Microsoft and Apple. Eventually, Microsoft won the right to release their own graphical interface. Windows 2 came out in 1987. The graphical user interface gives users images, pictures, things on the screen that are clickable. You can actually interact with, you can find, you can open, and it was modeled after this skeuomorphic system, right? This modeling things in the real world where files, right? Click on a file and open up a file folder and see what's inside. Why does this matter? Concepts and images are symbols. So instead of knowing what is possible beforehand, you can discover what is possible through interacting with the computer. You can learn by investigating. This breaks down the wall that was between computers and people and enables the public to use a computer. And here we are today. Back to our definition. So what are the other things that are, other than graphical user interfaces and computers, what are some other interactive systems? So there are many things, right? There's a lot of stuff. Anything that involves a human using some computation. So for example, software interfaces. Whatever software you're looking at that's playing this video, that has an interface. Also, Pokemon Go games, right? Console games, virtual reality headsets and software, tablets, smartphones, watches, anything that involves a person having to impact or get information from a computational system. HCI also looks at processes, like the way we use AI in our systems that guide societal choices. If you are a person who likes pictures and models, you can look at this model and you can view interactive systems through this very broad, generalized model called the Universal Systems Model, which maybe you've seen in a generalized engineering process class. 5 components: goal, input, process, output, and then iteration, sometimes called also feedback, which is checking to see how successfully our output met our goal and making some changes. Here's an example. Nintendo Switch Sports, this was Wii Sports in my day when I first started playing. You have a goal, which is to simulate a tennis game or a sports game, whatever. Let's do tennis, a tennis swing. The input of the system is the controller sensor, capturing some movement data. The process is the console looking at that movement data and mapping it into responses that make sense in the game. The output, or the media feedback, like in the game, is your little character swings the tennis racket or whatever game you're playing. And maybe you hear a quack sound when you smack the ball. The iteration and feedback is that the user, in this case, sees how their swing translated into the digital world. And maybe it was a great swing, and you hit it and you got the points. And they're like, okay, I'm going to do more of that. Or maybe it was a miss, and they modify their swing the next time to play a little bit better. So what's the career here? The career is called interaction design. Interaction designers are people who study how humans use technology and use their insights to make the process of using technology a little bit better. Interaction designers help make your experience with technology easy and hopefully delightful and enjoyable to use. And getting this right is not an easy process. I'll give 2 very quick examples. Elevators. Clear the buttons, you press and you get to the floor that you would like. Press the closed door, doors close. This should be very simple, easy to get wrong. So here's some examples of confusing, bad elevator interface design. What do you press? In the middle here, do you press the white button on the right to go down or the one on the left? I don't know. Maybe just press them both. See where you end up. I have no idea what these other numbers mean on the 3rd example over to the right. What are these? I mean, why is the 3 there and the 2? I don't know where I'm going. Another example of interfaces, especially bad interfaces you've probably experienced, are web interfaces. This is an old example from the New York Times, and it's fine. There's nothing terribly wrong with it, although you'll notice that there's ads everywhere, which is not great. Another example is the pop-up notifications, something where the computer mandates they need something from you right now. And this one is so confusing. Are you sure you want to cancel this order? And your choices are okay and cancel. So then I think they tried to make it a little bit more clear by indicating some instructions here, but I don't think it really helped. Another problem could be error messages, where you're trying to do something and it won't let you. And how is it going to tell you whether it's success? How is the error message communicating to you what you're doing wrong? So sometimes we speak of the history of computation as having 3 waves, okay? The mainframe, the personal computer, and ubiquitous or embedded systems. And this terminology is attributed to Mark Weiser. also known as the father of ubiquitous computing and calm computing. The three waves of computing are important to think about because oftentimes we think about just the personal computer, our personal devices, in terms of interaction design. But we also have this third wave that Mark Weiser is predicting, which is here now, called ubiquitous or embedded systems, where technology is receding into the background of our lives and is embedded into our everyday objects. This includes things like smart thermostats that can track when you like your air conditioning to be on and when you like it to be off and what temperature you want it at, and then predict what you want your thermostat to be set at. Also, when Google gives you notifications because it knows your calendar event is starting soon and you're not there because it also knows your location and it gives you a little ping like, you might want to leave soon. Okay? This is also ubiquitous or embedded systems. Also, if you get in the car and your phone switches to auto driving mode, another example of the computer anticipating what the user needs. HCI encompasses all of this, and the research and the work being done in this field helps us pave the way for smarter and better and easier to use and more helpful human-centered computational systems that address key needs in our lives by taking a holistic, human-centered approach to technology design.